awkward on this computer. And like I said, I probably won't go to the document camera too much today. I'll probably just go into Word. So I'm going to share screen here. Okay. All right. So let's talk about, so we've spent some time last couple of class periods talking about using SolidWorks. You guys have done some of the tutorials for us now. Let's talk about some basics here. So we talk about some sketching concepts. Some sketching concepts. Important thing that we've not spent a lot of time talking about within SolidWorks is the smart dimension, right? They've had you do some smart dimensions. I've kind of mentioned it just a little bit. Very, very, very powerful tool, the smart dimension. I can't state to you how good it is in the CAD program to be able to, if you need to change the size of something, you just slap a smart dimension on it to find the value of that smart dimension, and it changes the size of something. That, for those of us that have grown up with modern computers, it's like, Steve, isn't that expected? Yeah, that for us, that's expected. Prior to the 90s, that was not, if you use older CAD software, if you drew something and you needed to change it, it was easier to just delete it and redraw it the right size than it was to say, you know what, you're not 3.5 anymore, you're 3.75. We can do that now because we have the modern computing ability and the software is caught up to that. So the smart dimension, again, it's real easy to take it for granted how powerful that is. The idea of a smart dimension is it allows us to define the size and location of sketch entities. Okay. We're going to talk a little bit today about fully defined. Okay. When something is fully defined, that means the size and location are completely specified. So for something to be fully defined, that means the size and location are both completely specified. Projectors being wonky on us here. All right, so if I go into SolidWorks real quick here, and we start just a new part up, and you don't have to do this, you're more than welcome to just watch and follow along here. If you want to do it, that's fine, you're welcome to. Hopefully we don't completely crash this computer running Zoom and Word and starting a part file. Here we go. Okay. So if I start a part file now, so if I start a sketch, it wants to know where do I want to put the sketch. Well, I'll just put the sketch on the front plane. All right, what do we want to draw? Well, if I draw a rectangle, just wow. If I draw a rectangle, just kind of out here arbitrarily. Now, one thing that the tutorials mention just a little bit, but don't talk real heavily about is relations, right? Built-in relations, geometric relations. We're going to talk about that in just a second here. Notice that if I hover my mouse right here to the origin, this is the origin, right? The 0, 0, 0 location. I get this little yellow symbol right there next to the cursor, and that yellow symbol says, hey, right now I'm going to put what's called a coincident or coincident relation to this corner of the rectangle and the origin. I'm going to put them together. They're going to touch, if that's where you want them. If you don't want them there, then just put it out here somewhere. But you have to be aware, and I've talked before about, don't just go in here and start clicking. Before you click, hover to and have an idea where, what is it that's going to happen when you click. If I just click out here right now, there's nothing going to happen. It's just going to drop the first corner of the rectangle, and I can come down here and drop the second one. Now, if I want the corner of the rectangle to be on the origin, I can do that initially, right? I can just make that my first click. But let's say I forget it, right? Or I miss it, or so and by the way, I hit the green check to release the rectangle tool. Excuse me, rectangle tool. Now let's say I missed that and I want to add it later. Well, there's a variety of ways I can do that. See, down here at the bottom, it says underdefined, right? Underdefined. That means the size and location of everything is not fully defined. There are things in this sketch that could be changed right now. Right? It's underdefined. There's some size and location that are not fully defined. Come on, projector. All right. So there's a couple, and what that means, the things that are blue can be, I know, it's really, I'm going to put in an IT work order and see if there's anything it can do. But the things that are blue can be moved, right? I think it's just a RAM issue. We're really pushing this computer to its limits. So the things that are blue can be moved, right? So if I were to grab this corner, if I click on this corner, and if I hold down the control key on my keyboard, control key will allow you to select multiple individual entities. So holding down the control key, I can click on the origin. And it says, hey, what do you want to do to that? How do you want those two to relate? Well, I can make them coincident. Right? Again, something else that in older CAD programs, it would be way easier to just delete the whole thing and draw it that way the first time than it is to go back and change it later. Modern CAD programs are designed that way. You want to change it? Change it. That's fine. It's no big deal, right? That's the way modern computers work. Yeah, change it. So now and see this green thing now, this is what we call a relation, okay? So we've talked a little about fully defined, and we can use smart dimensions to fully define something. There are two ways, I'm going to bold and underline, two ways to define a sketch. And we'll talk about this so many times this class, you're going to get tired of hearing me say this. And hopefully it becomes a gag reflex. You tell me the two ways to define a sketch. That is my goal. Two ways to define a sketch. Number one is through smart dimensions. Number two is through relations or the geometry. You define the geometry, basically, of your sketch. And those are the two ways we can define a sketch. So we'll go back to SolidWorks. So what I've done now is I've put a relation. This corner of the rectangle is related to the origin by what's called coincident. That means they touch. They're together. So I've said this corner of the rectangle is on the origin. Now the sketch is still underdefined because and you can see that I have some lines here that are blue, if you can see colors well, right? That means the things that are blue can be changed somehow. And sometimes you can click and drag those and move those. That means we've not said how big this thing is. We've just defined its location. One corner of this rectangle is on the origin. That's its location. Now, if I define the size using some smart dimensions, so if I say, well, smart dimension this side, and so again, the way you smart dimension, you select what you want to dimension, and then, or select multiple things you want to dimension between, and then just drop the dimension somewhere out of the way. And I can say, all right, well, let's make this 1.5, and I'm currently in, I think, inches, so 1.5 is okay. And now that side is defined as 1.5. And notice this line up here now is now black, right? Because that means I've defined the distance between this line that was already defined and this line. Now, so I've defined the vertical dimension or the vertical distance. I'm going to define now the horizontal distance. So I'm going to click on this line and say this one is 2. Now, notice I get a message down here at the bottom. It says fully defined. And I know it's hard for you guys to see from the projector, but down at the very bottom, it says it's fully defined. But prior to that, it said underdefined. Fully defined means I've defined both the size and location of everything within this sketch right now. Nothing can be changed unless I change some of these, either the relationships or I change some of these smart dimensions. That's the only way I can change things right now. I can't just click and drag things that are fully defined, okay? This is the only possible way this rectangle can exist, is the way it's being displayed right now. That's the other thing fully defined means, is this is the only possible way this can happen given these parameters. Okay. A couple of things to mention here, right? So we talked about in sketching concepts, we talked about release the tool. Right? And the other thing to mention here is exit sketch. Right? When you're done with the sketch, exit the sketch. Tell it you're done with the sketch. And the other thing is, here it still says, hey, do you want to keep adding dimensions? If I click on something else, it's going to throw more dimensions on there. And I'm fully defined. There's no more dimensions to add. So I need to tell it I'm done drawing dimensions. So either hit the escape key, click smart dimension again, click the green check, somehow tell it you're done drawing dimensions. That's release the tool. When you're done with the sketch, there's a button up here that's exit sketch. And by the way, once you get further along in the tutorials, it's going to assume that you know how to exit sketch. It's just going to be in one of the step 1, step 5 is going to say exit the sketch and then start a new sketch or start the feature or something. It's just going to say exit the sketch and that's it. And it's going to expect you to know that just means click on this button, tell it, hey, that sketch is done. Let's do something else now. Okay. All right. So again, important sketching concepts. Be able to use smart dimensions. Be able to use, we're going to talk more and more about being able to use relations. And we'll see that more and more in the tutorials. But somehow we need to define both the size and location of sketches, especially if we're dealing with, like today, you're going to be building things that are mating together. We're going to be building parts that fit together and go together. And so it's really important that all of my features are not only correctly sized, but they're also correctly located. Okay. So, all right. And if I'm just arbitrarily drawing something just kind of artistically or as a concept in SolidWorks, and it's not going to fit with something else, then I wouldn't necessarily have to fully define it. It is pretty forgiving. You can create things that are undefined. But if you're going to make something that's going to interface or mate with something else, you really want to fully define it as much as possible. Questions for me so far? Okay, let's keep going, shall we? All right, so, and again, I'm just kind of going over the main stuff that we should have picked up in tutorials for lessons 1, 2, and 3. Okay. Now, so we've talked about extrusion features, all right, or extruded features. We talked about these guys, and that is both, of course, the there we go. That is both the cuts and the boss base. Now, these work a couple of ways. These can be, the way I normally do these, the way I normally create one of these features is I like to start the sketch. Okay, I like to start a sketch. And then after I start a sketch, then I like to draw a sketch. And then I like to exit sketch. So I like to do my sketch first. That's me. And then once I've got my sketch made, then I like to start feature. And then exit feature. And I'll show you what I mean by that in a second. Okay, that's the way I like to do it. I like to draw the sketch first and then use that sketch to make my feature. The tutorials do it a little different, and that's okay. They like you to start the feature first. They'll tell you select extruded hole cut, right? And make an extruded cut. And once you do that, then what you have to do is you have to start the sketch, because it needs to know what sketch do you want to use to make this extrusion. what does the cross section of the extrusion look like? And then once you start the sketch, then you draw the sketch. And I know this is like, Steve, what's the difference? Well, there's really not a lot of difference, but I just want you to know that you could do it either way. You draw the sketch, then again, as we mentioned, you need to exit the sketch. Tell it you're done with the sketch once you're done with the sketch. And then once you exit the sketch, if you do it the way they do in the tutorials, once you exit the sketch, then the manager will change and it will allow you to finish and exit the feature. Right? What's the difference? Nothing. You get to the same point. I'm just telling you, you can do it in either way. SolidWorks is almost to a fault. SolidWorks is very forgiving in what it will allow you to do. Okay. That's really nice when you want a lot of freedom and need a lot of freedom. It's really nice if you don't understand what that freedom does for you sometimes, right? So it can get you in trouble if you're not careful. And again, a common way is it'll let you make something that's not fully defined. And then when I go to, as you guys, some of you guys will see today in your assignment today, when I go to mate that with something else that is fully defined, they won't line up perfectly, okay? But it'll let you make it. But just kind of keep that in mind. And the same thing here, it'll let you start the feature if you don't have a sketch already in mind. And they'll say, okay, well, show me your sketch. Either select a sketch that exists or show me where you want to draw this sketch. And either way is perfectly fine. I don't have a preference. I do have a preference. I'm going to draw the sketch first and then make the feature from it. But either way works. Okay. And again, today our focus today is to go back. I'm going to give you some objects to create in SolidWorks, and then you're going to fit them together in assembly. All right, so we're not going to do drawings today, but we are going to talk a little bit about assembly. Okay, and we talked about assembly last time, but specifically I want to take a minute and just talk a little bit about mates within assembly. Okay, so most of the time we're going to use a coincident mate. Coincident mate, which I've not spelled that right. Coincident mate. And the way I like to explain this to, especially to rookies, is think about this. What faces do you want to touch or be coplanar? That's what you want to think about when you're assigning coincident mates, simple mates. Is if everything I've got are normal surfaces or even inclined surfaces, if they're flat surfaces, what flat surface would I like to touch each other or be coplanar? Okay, now to show this off, I really need to, and there's something in here I want to show you that I like to call the magic flip button. And that's my words for it. It has a name. I think it might be flip orientation or something like that. There's a magic flip button. I want to make sure you see it because it's a very powerful little tool. Okay. All right. To make an assembly, I need a couple of parts. So I'm just going to make a couple of parts real quick. I've got a sketch already exists. I'm going to go to features. I'm going to make an extruded boss base. It says either select somewhere to draw a sketch or show me a sketch. Well, I've got a sketch. Here's a sketch. Okay, let's make a feature from that sketch. Awesome. That's I think it's 1.5 by 2 is what I made that. So let's make this 1.5. Okay, and let's do something interesting to this so we can mate it up with something else. Come on, projector. There we go. Okay. I don't know. Let's just put a hole in the top of this thing. Okay, so I'm just going to draw a circle. Okay. Now, if I go normal to that, I can rotate it around, or I can just go normal to that. Tell it I'm done drawing circles. Right. I'm done drawing circles. Now, again, that's an underdefined circle. I can click the center and move it. I can click the edge and resize it because things are blue. They're not defined. I've not defined the size and location of the circle. Let's define the size and location of the circle. So I'm going to throw smart dimensions on it. I'm going to say, you know what? Let's make this 3/4 of an inch is fine. Let's make 0.75. And the location, the way you can do a circle or any feature, you can define its location. First, select that entity. In this case, the circle. So you can select the center, or you can select the outer edge. And I want to say, well, let's define its horizontal location in this case. So I come over here to this line, click on this one, and now I'm saying this is the distance or the dimension between those two entities. So again, when I'm doing a smart dimension, select the entity or entities you want to dimension, and then drop that dimension somewhere with a final click. And then you can specify a value for it. Okay, so let's say it's I don't know, 1.25. So again, that is still underdefined. I've defined the size and I've defined part of the location. If I release the tool, right, to let them done drawing dimensions, notice this is still blue. I can still move it some. What can I, let's see, check that. What can I move? I think I should be able to move it vertically. It's not 1, 2 though, is it? Anyway, I know I can still move this thing up and down because I've not defined the vertical dimension. So if I grab the center there and I click one of these lines here, and now I can drop a vertical dimension. And let's say I don't want it the full 0.6 inches there. Let's drop it down to 0.5, and so that'll move it up a little bit. But now it's completely defined. Now it's fully defined down here at the bottom. Everything's black because I've defined both the size and location of this object somehow. Okay. I can do that through relations. I can do that through smart dimensions. Tell it I'm done with smart dimensions. I'm going to tell it I'm done with the sketch. I'm going to exit the sketch. And because I started with the cut, now it says, okay, well, how do you want to make the cut? What are the other parameters for the cut now? Right. So I'm going to rotate it around so we can see that. If I don't want to go all the way through, let's say I only cut 1 inch in, right? So it doesn't go all the way through now. And so I've got a circular hole 1 inch in. Right. I made that 3/4 of an inch, so I can mate this with something else. Let's make on this sketch. Let's make a sketch on this face. I'm gonna go normal to it. I'm gonna draw a circle on here. I'm gonna define its size. We made that other one 3/4 of an inch. A little bit later, we'll talk about tolerancing and about don't make something that goes inside something else the exact same size. We haven't talked about that yet, so we're gonna do it today, right? We're going to do what we call a line fit. That's okay. Come on, projector. Come back. There it is. All right. And then let's define its location. We'll just put this one in the middle. And so it's, I think it's 0.75 down. And if memory serves, this is 2 inches the other way. So we'll make it 1 inch this way. And there are other ways we can put that in the middle, but smart dimensions gets us there. Okay. Exit sketch. Now, again, this time I started with the sketch. I didn't actually start with the features. I just made the sketch first. But now that I have a sketch, I can go to features, start as extruded boss base and say, it says either show me where you want to draw the sketch or select a sketch. Well, I have a sketch. Let's select it. And I can make the sketch. 1 inch is just fine. Okay. I'm going to save this part. File, save as. I'm just going to drop it in documents or downloads. Documents is just fine. We'll call this demo. I've already got a demo 1. We'll save over the demo 1. We'll save over demo 1. That's okay. Yes, replace it. Okay. Now I have a part file created. Now let's make an assembly from this part. Okay. So I'm going to go file, new. Let's make an assembly. Really tax the system. Hold on, computer. All right. So when you make an assembly, the first thing it wants to know is what's the first part you want to drop in there. Well, it says, hey, you got demo 1 open. Is that what you want? All right, that's fine. Click on demo 1 and you should be able to just drop it in here somewhere. Now, if you want, you can put it on the origin of the assembly, and you need to do that before you start. It looks like it does that automatically now. It didn't used to. Yeah, it looks like it's, nope, they're not. See, this is the origin for the demo 1 part, and notice the origin for the assembly, and I didn't get those lined up. I didn't intend to. I didn't care to. You can, but I didn't. Right. So there's a front, top, and right plane for the assembly. There's a front, top, and right plane for each individual part. There's an origin for both of them. You can make them line up. You don't have to. It just depends on what we're doing with it. All right. So I've got one part in here. Let's insert another one. And I don't really have anything else, but I do have this demo 1. I've built them so they'll interface together. So I can actually just drop as many copies of demo 1 in there as I would like. And so I have now multiple copies of demo 1 in there. I could put a whole bunch in there if I actually want to. Let's talk about mates, right? What are we talking about? Well, assembly. We're talking about mates. Let's talk about the coincident mate. Okay. So I'm just going to arbitrarily drop these in there. Oh, that's the wrong one. This one. Let's go to the assembly. There we go. I've just kind of arbitrarily dropped these in there. The first one you drop in, this is the first one we dropped in. If I click and try to move it, I'm getting a message here. It says the selected component is fixed. It cannot be moved. By default, the first one you put in assembly does not move. It's fixed. You can float it. You would have to right click on it and tell it you want it to float, and then it will move. I would suggest be very careful having everything in your assembly floating. Right? Now, if you wanted to move this back to the origin, then you would probably have to float it and then put it on the origin, and then it would fix it, and then probably fix it to the origin somehow. But I'm okay with this guy just fixed where it's at right now. And then everything I insert after that, I'm going to attach to it. Okay. How do we attach it? Well, we attach it with mates. And I said for the coincident mate, think about what faces do you want to touch or be coplanar. Well, what I'd like is for this, well, let's do this. Let's start with this face right here on the peg. I would like to touch this face down there. And those are the two faces I want to touch. Now, one might look at this and say, Steve, that's not what I wanted at all. Well, it's doing what you told it to do. I haven't yet told it put the peg in the hole. I've just said put this face, and you can see what it's done. I've said put this face in the same plane as this face. That's what it's done. That can exist in a variety of ways, not just inside the other. I have to force it inside the other, and that's easy to do, but that's going to require another mate. Three-dimensional objects will need 3 dimensions of restraints, if you will. 3 dimensions of restraints. I'm not going to talk a lot about degrees of freedom, but we have multiple degrees of freedom. Okay, there's multiple ways I can achieve exactly what I've got there. And by the way, I mentioned earlier the magic flip button down here in the mates when I've got one active. This is the coolest thing. You can flip it because that's also true, right? It's not what I want, but that is true. If the only thing I'm saying is these two faces have to be in the same plane, that can exist in a variety of ways, and I can flip that either way. Very personally, very rarely, once I insert a component, very rarely do I try to move, manipulate, and rotate it to get it close to the other one I want to mate it up to. I just use the mates and let them line it up. I don't fidget a whole lot with trying to move and rotate the components. I do it through mating, but it's okay to do it. If it makes it easier to mate them up, get one close to the other, go for it. Now, again, this is not the configuration I want, so I'm going to push the magic flip button going the other way. That's the configuration I want, right? I want them this way. But again, this is not all I want. All I've done is said these two faces are coincident. They are coplanar. So that's the first step, right? Now, the other type of mate we can talk about, and we haven't seen the tutorials yet, and we probably won't for a little bit. We will see them, just not yet. There is what's called the concentric mate. That is where cylindrical or spherical surfaces have the same center. Very simple, right? So what I can do here, I've got a couple of cylindrical surfaces. I've got a cylindrical surface here, and I've got a cylindrical surface there, and I'd like them to have the same center. So I can say, well, this, and notice what happens when I select this, and you've got these options. I could tell it right now, hey, I'm going to assign a concentric mate, but I don't even have to do that. I can just say, hey, this circular and that circular, and it says, oh, you've got circles there. Do you want to put them together? Yeah. Now, if you want it to not rotate, you do have a checkbox. I can turn that on and off. I actually am okay with these guys rotating. So I'm going to leave it off. I'm going to hit check. Okay. And so I'm going to check. I'm done with mates for right now. I'm going to check that. And so that can exist, again, in a variety of ways. Right now, I didn't lock rotation, so it's allowing that to rotate. Okay. Now, if I could either lock rotation. Another thing I could do is say, well, I don't really want it to rotate. So one thing you can do is say, well, this face and this face, and they can't be coincident because they can't line up perfectly, but you can force them to be parallel, right? And that's what it's saying. It didn't give me coincident because it knows they can't be coincident. They can't be coplanar, but it will allow them to be parallel. And I think that will force it to where it, yeah, see, I can't rotate this one now. Okay. Now, if you put too many mates in there, they're down here, just like anything else, you can modify it. I can open this up and you know what? I want those to rotate, so I can just delete this parallel. Yeah, that's fine. And now they rotate again. Okay. I can put more in there. So let's say insert another, let's just insert another copy of them in there. So we'll drop another one in there. Okay. And so let's say that I want to, let's make this one up. So again, if I'm doing just coincident faces on normal surfaces, coincident mates on normal surfaces, what I suggest to rookies is let's just mate faces to faces. You can mate lines to lines. You can mate points to lines. You can mate points to surfaces, a variety of things. You don't have to go face to face, but it's just, I'm just from experience, and you're more than welcome to experiment with that. I'm not telling you you can't. I'm just going to teach you guys mating faces to faces, and then you'll kind of figure out more as you need to. Okay. And the tutorials will show you some more as well. But let's say that I want to mate this face to this face. Okay. And again, the common thing might be to say, well, Steve, I mean, they're not touching. Well, they are. It's just, it can exist in a variety of ways, and be very careful moving things around if you don't have them heavily mated, because it's really easy to move this and it ends up like out here, way out here in space, and they actually end up a long ways apart. They can exist. All I've done is said these two faces are coplanar. It could be here and to I-40, and they're still coplanar if they're lined up, right? I've only defined one direction. I've defined how these two, right? How these two faces, this one and this one, I defined how they interact in the X direction, and that's it. I still have Y and Z if I want to lock them up. So if I want to lock them up just with normal surfaces and coincident mates, I'm going to need at least 3 mates to do it. So what I'm going to do is I'm going to say, well, let's mate this face to this face. And it's still, Steve, they're still not. No, well, yeah, they are. They've actually done exactly what I told them to do. It can still just exist in a variety of ways. But see, here's the thing. Basically, now I've defined in the X and the Z direction how these two interact, but I've not defined in the Y direction. So it can still move in the Y direction. If I want to define in the Y direction, I'm going to do this. I'm going to define, well, let's put, and this one, I'm going to mate to this one. So I'm going to put this on that. That's okay. Right. And because this one's locked in, I've mated this one to this one. This one can't move up and down. There we go. This one can't move up and down, and that's going to lock this one in. So this one's fully defined. This one won't move. But this one is still, I've made it in such a way that this one will still rotate. I can mate it where this one can't rotate. I didn't necessarily want that. Questions here? I wanted to try to give you as much time as I could to work on the assignment today, but I did want to go over some things and kind of redefine some things that maybe they talked about in the tutorials. I know some of them they didn't in detail, and that's okay. Tutorials are really good at explaining to you how to do things. I try to take a minute or two after we do some tutorials and explain to you why we're doing the things we're doing and how they help us moving forward. Okay. And our goal today is have you make something without step-by-step instructions using what you learned in the other tutorials. Feel free to go back to the tutorials. It's like, how do I make an assembly? Well, go back to the tutorial and it'll explain to you how to make an assembly based on the parts you've got. Okay. So use the things you've learned in those tutorials. Last thing I'll mention, most of you, I've probably talked to you about this. It's important we make sure these are all built because they're going to mate together. We all build them probably in the same units. I would suggest working in inches today. Down here in SolidWorks, I think I've showed you most of this. There's right now I'm setting IPS. There's a little thing down here in the bottom bar. If you click on that, right now mine says IGS, yours might say MMGS. You can switch between inches, millimeters. We probably won't use centimeters and meters in here. Normally we'll work in either millimeters or inches, depending on what we're working with. I would suggest, I've built these parts in inches. I would suggest making yours in inches. A lot of times the tutorials are in millimeters, and either one's fine, just be consistent. But these are made in inches. So when you put a ruler on the drawings, they'll come out to probably the nearest half or quarter inches. Okay. Questions here? Okay, let's look at, I'm going to stop recording. Okay, so I'm going to stop share. I'm going to stop